Hello, hello. Welcome to today webinar. It's good to see you back and to have you back from holidays. Our last webinar we're back in July, so almost two months before. So I hope you had a good summer break and you are not too much catch up by the activities starting back in September. Many of you were in ONS or in Gastech, so we had the opportunity to meet a lot of people, and I hope you get the fever of the business that we had at the beginning of September, where everybody was running right and left to find orders and to find projects, which are many currently. Thank you for coming to today's webinar. We are going to talk about carbon capture within decarbonation. This is following a little bit our pace of webinar. We try always to, let's say, have one over the market, read market trends globally, and then we try to have one other following more thematic over a topic which for us is interesting and moving into the market in good direction to explain what is happening, etc., etc. Just starting this webinar, I would like to, of course, mention that we have our next webinar already planned. You can go in the conversation of this meeting, and you will find every link. As always, our next webinar will cover the topic of gas and LNG, global outlook. Of course, it's a big topic currently due to the Ukraine crisis. A lot of things are moving, and we try to explain what will happen, what has happened already, and what is going to happen this winter, and what will happen, of course, on the next 4 years outlook over the gas market, because it's a big shift into the gas market. So a lot of opportunities of business and a lot of trap as well. So that's why we'll come back on October on this topic. Okay, we try to cover usually this one vastly, not leaving aside the oil, but really focusing on the gas market, the production, the midstream, and also then the petrochem activities. If you're interested, you can have the link directly into the conversation, or you can send me an email and I'll send you back the invitation. As always, during this webinar, I'll present the slide, starting through it, and at the end, we'll take all the questions. So if you have any question, do not hesitate to post it directly in the conversation of this webinar. If we don't answer it directly, it just means that we will take them at the end of the meeting. And again, as always, if you're interested by the slide I'm going to present today, do not hesitate to send me an email at guillaumejean@tobefirstconsulting.com, and I share with you the slide later tonight or maybe early tomorrow. So let's go. Let's go with a small introduction. Small introduction about yourself. Normally, if you are coming to this webinar, you already know us more or less. Jean-Charles normally is connected as well. Most of you know him from his background in ABB, where he was vice president of the group in charge of all the oil and gas market. And in fact, we started a little bit developing this database, Project Smart Explorer, for which we try to base all our data from. And myself, I started in Siemens and then joined the family business To Be First Consulting to help him growing this business into oil and gas and then petrochem, of course, but then energy transition, etc., etc. You know how it comes. And this webinar is part of this service of Project Smart Explorer that we are happily providing to our fantastic customers. So about the database, you may have seen it on the last month. It has been growing and growing quite frankly since January, because usually we're seeing, okay, it's about 1,000 projects at pre-feed and feed. And now we realize that energy transition is really taking a big momentum. And you can see on the right of the screen that we have more and more application going into this energy transition. Electrification, e-fuel, e-methanol, energy storage, hydrogen, all the solar, power gen, waste treatment, etc., etc. And of course, the carbon capture, which is today's topic. So we were, okay, let's not limit ourselves to 1,000 projects, but let's grow this energy transition. And that's why now we say, okay, we have about 1,500 projects at pre-feed and feed covering oil and gas as always, keep petrochem as always, and now more and more energy transition, trying to have all the process infrastructure and opportunities we can have into this scope. So that's a little bit the last evolution. Now, if we focus really on carbon capture, utilization, and storage, I say a lot carbon capture, I say CCUS, CCS, CCU. all these variation. This is the umbrella we cover behind that. CCUS it really stands for carbon capture, utilization, and storage. Of course, we have those in Project Smart Explorer, but then you find a lot of variation of this type of project. Sometimes you only have the carbon capture, or only the storage, or the transportation, or the terminal, or the utilization. And more of those projects are, let's say, by themselves and quite independent just by existing. And then we have many opportunities which are linked to carbon capture, but linked also to other processes, okay, where carbon capture is part of, let's say, energy hub or recycling hub, carbon hub, the wording you like. And we see more and more, for example, for carbon capture opportunities while revamping brownfield units, which were gray hydrogen transforming to blue, and all the variation of blue hydrogen you can find blue ammonia, blue hydrogen, blue methanol, etc., etc. On the last months, we also have seen starting, and when I say last month, I would say 8 to 9 months, downstream carbon activity coming on the market, and that's really a reference to the utilization or usage, where we see more and more downstream application for carbon recycling to produce methanol, for example, by combining CO2 with hydrogen, green hydrogen, or producing carbon black, or recycling CO2 into plastic. So we see that those applications more and more, and we'll have a specific focus on that. But just so you know, all those applications are covered in Project Smart Explorer. If in the coming months or years, new application about carbon capture will appear on the market, we'll add them to the database. And of course, we'll try to follow up as fast as we can on those new opportunities as well. Just one comment. If you're interested by this carbon capture and want to know more, I can only advise you to go back to our first webinar we made just 1 year ago. So it was, I think, the 31st of September 2021, where we were really talking about the basics and really the technology, the technique, the processes of carbon capture, how it works, what is behind, etc., etc. And you will see we have made a little reference to this last year webinar. But again, this webinar is available on our website. You go to twifirstconsulting.com, you go to the tab webinars, and you can find the video. It's on YouTube, so it's free access. You can share it and watch it whenever you want. If you have any question also regarding this webinar, do not hesitate to ask us. So that's the recap. Now let's go a little bit more into the heart of today's presentation. We try to start by the big picture, okay, what is happening from big market perspective, energy perspective. Then we'll go down really to carbon capture, and then a little bit more specific. And then we'll try to expose some what we seems really interesting for us on this market. Again, if you have any questions, do not hesitate to ask them. We will cover them at the end of this webinar. So I think it's quite interesting what has happened on the last few months, but also a few days or even a few weeks. For those like Jean-Charles and I who were in ONS, we are really surprised, but quite also happy to see that people started to be a little bit more pragmatic, and we could not do better than quote Elon Musk, who was also invited to ONS, where he said, okay, he said a lot of things, but part of this was covering really the oil and gas, and he said, okay, world need more oil and gas, not less. Currently, at this specific moment, because we're in troubled times, there is big energy, not crisis, but at least tension that we all know about, with different reasons behind. And he had two things which were really interesting, and I put them just below, where he say, okay, let's not demonize the fossil fuel because we need them. But the way out, as he said, was to see, okay, let's find a clear path to sustainable energy future. And that's an evolution we have seen on the last month, where people were only talking about renewables all the time. And people start to realize that as soon as the energy market was in tension, that renewable by itself was not the, let's say, an answer by its own to the energy, let's say, the need we have in the world. And of course, oil and gas was needed for at least a long time, if not ever forever. For the energy, let's say, piece of our planet. So the idea was to say, okay, let's not say we are going to pass over oil and gas, but we just need to make oil and gas sustainable. And that's, let's say, a message we are trying to pass through our different webinars and during our intervention, and speaking intervention mostly, where we say, okay, we can't, let's say, cut and transition from oil and gas to something else. The idea of energy transition is mostly how to clean the activities we have around oil and gas. And that's where carbon capture is a solution. Because you can't electrify everything. So using electrification for some application, green hydrogen for others, and carbon capture, here you start to be able to cover all the application and be able to have a sustainable energy future. And that's what we see also in the figures and in the project, where the world is turning a bit less, let's say, focus on renewables and more into decarbonation and all the application I've been quoting. Just to put carbon capture in context, I think it's quite important to realize that carbon capture is not only about CO2. Okay, CO2 is for sure the biggest culprit as we know it. But in fact, if we look on the numbers and you have them on the right, if you see the list of gas that are participating to greenhouse effects, in fact, the CO2 is the less harmful one. It doesn't mean it's not harmful because it's still, but it's the less harmful one. If you compare that to methane, methane is between 25 more times harmful to 40, depend the figures you find on the studies. But then you have also some gases which are NOx, hyperfluor, or hexafluor, triofluoride gases, also with nitrogen, etc., which are about 10,000 times more harmful, or even sometimes higher, 20 times more harmful than CO2. So the complexity is quite bigger because it means that the capture and the carbon capture is not only about CO2, but it's about many gases. Of course, CO2 is the less harmful, but it's the one representing the biggest amount of volume. So it means that carbon capture, you have different market there. You will have niche market about what are called the NOx gases and the methane, which today are not tolerate anymore. I mean, there is no project around the planet which is going to be able to say, okay, we are emitting this amount of methane, we are emitting this amount of NOx. There is no industry in the world where people are living this being done. So of course, those gases are really well covered with many projects to diminish their emission. And for example, the last example was in US, where the energy plan from Joe Biden was to say, okay, we are going to close all the former field, US oil and gas field, which are emitting still methane because they have not been closed properly. So here it was a big move because the US was the last one a little bit to tolerate that. But of course, it's a big hunt over the planet over methane and NOx. Then CO2 is, let's say, the biggest challenge because that's where the volume of emission is. And of course, we need to tackle that as well. Just talking about methane, and then we'll cover more, let's say, the carbon. But to put that in perspective, methane is, yes, as I say, between 25 to 80% more problematic than CO2 for the global warming. But if you look on what are the methane emissions coming from, we found this graph in the Financial Times, which was quite interesting. And if you start from the left, you have the level of emission you have but per source. Here you find the first block of fossil fuel or oil and gas mostly. Here you have the emission from agriculture and waste, which is about a little bit less than twice the size. And then you have, let's say, more natural causes like wildfire or wetlands and natural emission. So those green and red parts are, let's say, natural and are part of an equilibrium of CO2 and methane emission around the planet. Those blue parts are the ones which are problematic and are the ones which need to be diminished for methane, but also for CO2, because they are the ones participating to the greenhouse. And that's where a little bit the story starts, because for fossil fuel, you can use carbon capture clearly to tackle those emissions, and it must be needed or must be done at least. Because, okay, methane, when you catch it, either you flame it and you produce CO2, which is already good for the environment, okay, if you compare the carbon footprint, but not so great. But you can also capture this methane and give it an evaluation, use it, etc., etc. Then for agricultural and waste, The emission cannot be captured because they are too large, too big, but they can be recycled. And those emissions can be converted into biofuel, into SAF, into renewable natural gas. And that's what we have seen into our last webinar, not last, but the webinar from March, where we are talking about those applications. So that's how you can cover those parts of emission. No, of course, it's not enough, and carbon capture needs to be applied first on methane, and then, of course, on CO2, which is representing millions and millions of tons, as we will see. Carbon capture, as we said, and if you follow our webinar from last year, is really a broad market, which has been moving quite quickly on the last month. And what we would say were the usual carbon capture market was to say, okay, we are going to capture carbon and then store it on the ground. Today, 1 year later, I would say a second vision has arrived for carbon capture, where we see more and more usage of this carbon. And here we are a little bit in between on a market which has two visions. On one side, on the left, we have, let's say, the traditional approach, which was say, okay, we are going to make a carbon capture project. Of course, we are going to have a reduction of our carbon footprint by this amount of tons of CO2 or methane every year. And we are, of course, going to use this project to decarbonize an industry that we have around, usually the industry that can't go electric or can't go green hydrogen. Technically, those processes are quite easy. We know how to capture this carbon. Then you have, once you have captured it, transporting the CO2, injecting it on the ground is something which is not done frequently, but we know and we have a certain maturity into it. Also, it's a good way to recycle depleted or old asset field because, for example, you have nitrogen production unit of gray hydrogen. You put a carbon capture unit on top of that, and you have a blue hydrogen, which is quite sustainable. And then you can re-inject the CO2 you have captured into a depleted oil and gas field. So you just turn around more or less a compressor and you inject this CO2 on the ground. It works very well. We have seen a lot of projects like those. Those projects are quite good for the carbon footprint, and companies like Total or Exxon are quite good at doing it because when they invest 1 billion, they are able to say quite easy that we have reduced our carbon footprint by 1 million tons of CO2, for example. But those projects generate a lot of cost and they don't really create value. The second vision that we are seeing arise, which is not at the same scale, is to say, okay, we are going to capture carbon and then use it to do something else. And here it's not only reducing the carbon footprint, but it's also going, let's say, beyond by having a negative carbon footprint, because by recycling the carbon, of course, you are going to make an arbitrage between the carbon footprint you have on the emission and the produce you are going to use. And here it's a whole new industry of recycling carbon material, can be any of them, just using carbon and recycling carbon to be used as a feedstock. It's a whole new industry, as I said. We see unit of pre-treatment going on and happening in front of refineries to reuse waste, etc., etc., but also capturing CO2 and then trying to mix the CO2, for example, with green hydrogen to produce green ethanol. So those projects are not at the same maturity. They're still at the pilot and demonstrator phase, but it means that there are new projects, new processes being developed, and of course they are quite interesting to be used. And again, the vision is quite different because there it's not going to be, let's say, a problematic to manage the carbon, but a way really to create value on top of it. Even if it's really expensive today, the idea is to create value from the carbon which is going to be captured. So today we have those two visions on the market, and it's quite important to have them because from one project to another, you see that it's a completely different vision, and the way the project will act and the size of the project will also be different. The financing. Financing is a big topic, of course, for those projects and for carbon capture, because as we say 1 year ago, and it's still the case, when you launch or when an operator launch one of those projects, it's really hard to say, okay, we are going to generate money or revenue or cash flow from those projects. And what we see today and happening, because many projects of carbon capture are happening, the motivation behind are not, let's say, the financing of the project by itself. It's a bigger picture that we see. And we have put this weird equation that I do not like as an engineer, but is quite interesting. Because today, no company, no board of director, no government is able to say, okay, we are going to increase our carbon footprint. Anyway, companies, governments still invest to develop industry, to develop oil and gas fields, for example, etc., which is going later on to increase their carbon footprint. So it means that if they want to make a development which is going to increase their carbon footprint, they have somewhere else to invest to decrease this carbon footprint. And one easiest way to do that is to make a carbon capture usage or storage project. So today, what we see more and more into the financing of carbon capture project is to say, okay, us as an entity, can be a company or a government, we are going to make this investment, which is going to increase our carbon footprint. So we are going to make this green investment as well, to have a global carbon footprint, which will be neutral or negative. But of course, for you, it represents always twice the business because you have two opportunities. And that's the financing block scheme of those projects, because okay, even if the project there of carbon capture or carbon recycling is not making any money, if you have the big picture on the life cycle of the carbon, maybe you have a gas field just next to it, and the gas field production will re-inject the CO2 they emit just on the ground, so they have the air permit for this project, so they have a neutral carbon footprint, etc., etc. So it's always a big picture problematic where CCUS projects are coming a little bit to decrease the carbon footprint or to compensate a new investment. In the same way, and talking about the global big picture, we have to realize that we are today oil and gas companies and part of this oil and gas industry into a fight for carbon emission. Okay, I think everybody has understood that. And when you look at what the carbon footprint calculation is, you have always what is quite famous, the scope 1, which are the direct emission of your company, of the fuel combustion, your energy, etc. You have the scope 2, which is indirect carbon footprint coming from the energy you are using or the raw material, etc. And then you have the scope 3, which is indirect, talking about the product you use, the way your personnel fly around the planet, the waste you use, if you have vehicles, etc., etc. And when you have this entire scope, and any company worldwide can make this calculation of carbon footprint, we realize that only the oil and gas company have pledged to become carbon neutral. And today, Total, Exxon, Shell, BP, but all the big boys and all the oil and gas company worldwide has pledged to target to become carbon neutral. For the first one in 2030, more or less, like Equinor or Repsol from memory, and the others, most likely, they will try to become carbon neutral by 2020, in the year 2050. Sorry. That's being said, okay, oil and gas companies are today the biggest emitters. They try to, and they are going to become carbon neutral. But what about the other industries? And that's where another problematic that is going to fuel the carbon capture. Because let's imagine if we talk about the big boys, Amazon, if we talk about Apple, those big corporations, how can they become carbon neutral? And here it's a big question mark because, okay, they can source their equipment differently, etc., their energy differently, but at the end of the day, they have no way to become carbon neutral. So one way for them, and that would be more or less the only way to cover part of the carbon footprint to become neutral, would be to buy some carbon credit or pay other companies, mostly oil and gas company, to capture CO2 somewhere and to inject it on the ground. And that's a big question mark, and it will be a big fuel to all the carbon capture investment, because today it costs a lot of money, of course, to capture, re-inject, or to recycle the CO2. But at the end of the game, or at the end of the day, every company will have to work on its carbon footprint every year to become cleaner and cleaner. And some company will be able by themselves, by their own activities, to reduce their carbon footprint. But most of the company will not be able to do it themselves. They will have to pass by a carbon capture to have an effective effect on their CO2 emission. Okay, so of course, all the oil companies know about that, and they're all trying to develop the technology to be able to later on sell carbon credit to other companies. So it's a business which is not existing today, but will happen. Hard to say when this business will happen, but for sure it will happen someday, and everybody wants to take part of it. So now, going into, let's say, more deep down actual business, daily sales task, we try to say, okay, what are the project evolution we have seen on the last couple of months, and how you can play from that. Today, if we talk about the design of the whole process, because carbon capture is a little bit becoming its own industry, not to maximize, but let's say, okay, you have the oil industry, you have the gas industry. CCUS is a little bit becoming a copy paste from the gas to say here you start from the sources, you capture this carbon, then you transport it and you store it or use it. It's a little bit the opposite way for if you compare that to gas, because in gas you have the upstream where you have the big volumes, big equipment, etc., etc., and later you go in the downstream, more precise are the equipment, smaller are the valve, etc., precise. Carbon capture is a little bit the opposite, because where you have the capture, that's where you have the huge density of units, because you have many sources of CO2, and that's where it's always a little bit a small volume of CO2 that are going to be captured on some spot. So here it's small equipment, small valves, small pipes, etc. It's more or less always a chemical or membrane process, okay, to capture the CO2. Then the CO2 or methane or whatever gas is going to be a little bit more aggregated. And for the transport, we are going to find few units. So we go from many units to only few units, but here with large volumes. And from what we see, actually, the trends, most of the transportation of carbon will be done through its gas format. Okay, CO2 will not be liquefied or any other gases. Most of it they will be transported via trucks, via ships, or via pipeline into its gas format, because CO2 is a big molecule and it's easily transported without leak. Then that's where I would say the two visions start to differ, because today we are mostly into the, let's say, the storage project, where we find few existing units which are mostly depleted oil and gas field, where they have turned over the compressors and are going to inject the CO2 underground mixed with water, because injection of CO2 is more efficient when mixed with water. Okay, it's really easily done and it's quite efficient to start large volume. And here again, projects are existing, but they are large volume, so it's big equipment, big valve, big pipe, etc., that needs to be installed. At the opposite, the utilization or carbon usage is really a new trend that we see on the market, and here it's moving a little bit on the other direction. It's few pilots today and few demonstrators we see around on the planet. Usually it's in big connection with hydrogen and green hydrogen for part of it, where people are trying to say, okay, we have CO2, we have green hydrogen coming from renewable electricity. What can we do? How to combine them, etc., to recreate ethanol and some plastic equipment. And here it's small volumes today, but people are planning to, of course, increase this volume and to grow this business. So as you see, it's a whole process, it's a whole value chain. There is opportunities for some people just in the capture, there are for others in the compression of the storage, and for people which are, for example, making small equipment, it will be more the capture and the carbon usage. For people making huge equipment, a huge valve, it would be more carbon transportation or carbon storage. So again, it's a whole, if I can say, upstream, midstream, and downstream application that you can find there. You might not be interested by all those applications, but it's quite interesting because everyone has an opportunity to go into it. Now going to, let's say, the persona, we try to say, okay, what is the today carbon capture and storage project where you can copy paste a little bit the designs organization. Okay, if we had to take an example which is well representative of today market and the project which are actually being developed or close to start, we took Dunkirk carbon capture because it's CO2 capture and storage, which is linked to a navy industry. And today, that's most of the projects are linked to a navy industry. In the example, ArcelorMittal steel plant in Dunkirk represent 5% of the French CO2 emission, okay, industrial emission, which is a huge volume, of course, of CO2 emission represented in France. And here, of course, it says French players have been quite quick to say, okay, let's organize a joint venture. So we find one user, ArcelorMittal, one IOC, Total Energies, one engineering Technip, and one public financing, the French government, to realize this project. Because even if it costs a 1 billion project, okay, 1 billion US dollar, the earnings of reducing the French emission by 5% is just huge. Okay, so even if the project costs a lot of money, it's quite beneficial for the whole, let's say, society and for all the players to acquire and to put financing into this project. Then once you have done the capture, of course, you need to do something else. And this CO2, once captured, goes offshore via ships and is injected on the ground into offshore depleted oil and gas field close to Norway, close to the Northern Light project, if you're interested. And it's a water injection, of course, and it stores about 4,000 tons of CO2 per year. Okay, so it's one location of capture directly linked to a storage unit, which is quite bigger. But anyway, they ship the CO2 back into vessel and is stored to 4,000 tons. So this is the project we see today. More or less the size is quite representative. And the logic behind this carbon capture is about this one. So it does not create money directly, but of course, when you reduce the emission by this amount, it has a huge value for the society. So you get a lot of public financing and the technology goes very well as well. Keep in mind the size of this project, 4,000 tons per year of CO2. Now, if we go to two more projects, and here for this this example, we took green prairies from Summit Carbon Solution. And here the CO2 capture, just to give you the size, will capture the CO2 in 32 ethanol plants in US, okay, which are over 5 states in US, and which are linked together to a unit of midstream to carbon transportation, which is a pipeline of 3,200 kilometers. So it's a huge installation. And today, or let's say tomorrow, the carbon capture project, as we see them arriving in the database, are mostly like this, a little bit a grid of carbon connecting many regions to capture the CO2. Okay, it's quite interesting to see. For example, in Europe, we may have Northern Light, which is close to that, or in UK, we have Humber Port, etc., etc. So it's more and more coming, let's say, a network of carbon capture, collecting CO2 from everywhere, injecting it to a pipeline or an offshore midstream transportation unit, and then going to one or few storage locations which are already existing. And here in this project, it's 3 locations of storage which are filled in North Dakota, which are close to each other, which are already existing, already identified, already developed because they were former oil and gas field. And here we are talking about storing 12 million tons of CO2 per year. So you see the gap into size, where the previous project were 4,000 tons, and here it's 12 million tons of CO2 per year. Okay, so it's complete different scale that we see for projects. And of course, the project today, where it's a little bit small size, even if it's good business, I mean, we're talking about investment in 500 million, 1 billion for a few of them. Today, the ticket for network like this of carbon capture, it's more above 4 billion, sometimes 5. And the biggest I think we have is about 10 to 15 billions investment for carbon capture. Because when you scale up, of course, you are going to inject a lot of more cash, let's say, for this project. But in the meantime, you see it's a huge, let's say, carbon reduction that you can achieve with just one project. Now going to the carbon capture, utilization, and storage market. Here we'll try to give figures. As I said, we made a webinar about carbon capture last year, and that's just to give you the comparison of the vision we had last year in 2021, which is the top line, and the vision we have today in 2022 about the market. And it's quite interesting to see that, okay, let's see the profile of the investment. Here you have the CapEx invested year to year into carbon capture project and, okay, CCUS, all those projects. You see this wave in 2021, what is quite reflective to the one we see this year. What is really different is the scale you have. Here, the figures, they are in million US dollar. And you see the year 2023, which was, let's say, the tallest pie we had, was about 10 billion investment just on the year 2023. Today, 1 year later, the pile of investment we see for 2023, so for next year, is about 30 billion. So it means that the market vision increased by threefold in just 1 year. Okay, and that's next year. Okay, it's not in 15 years, etc. It's tomorrow market, which has just in 1 year grown by investment in 3 times, which is huge, of course. And you see the following year it's not scaling down. The second topic and comparison that was quite impressive is also the difference in type of actors. Last year, we saw a market which was 10% of IOCs, meaning international companies, Shell, BP, Exxon, the big boys. Then it was 44%, sorry, represented by the national oil company, so the Equinor, the Saudi Aramco, Petrobras, etc., national oil company. And then it was 46% represented by the independent company. So really companies which are privately owned or which are not even public in most of the time, mostly British or let's say UK and US companies or some Asian companies coming on top of that. And when you compare here the volume, or let's say the split of the market with today, you see that the IOCs maintain the market share. NOCs reduce a little bit the scope from 45 to almost a 1/4 of the market, but the opposite, the independent, they grow like crazy, their market share, because independent, privately owned business, let's say right arm of banks, are investing like crazy in those projects for many reasons that we could spend hours discussing, but you see that the type of operator which are investing is less known, of course, because those independent companies have less visibility, but today they are the one doing the market. And you see the increase in the market by 3, okay, is mostly, let's say, the result of those independent investment. So if we only focus on 2022, you see that the scale just going crazy is huge. Of course, it's not going down. Okay, it doesn't. Or if it's going down, it doesn't mean that the market is disappearing. It just reflects the vision we have today on the project already existing. And here, having a pie this big on the future is a huge forecast, which means that okay, we know that the business forecast for carbon capture will be full at least until 2026 from what we see today, because many projects will come on top of that. And we are again here today just starting to absorb the wave of carbon for the wave of project for carbon capture, usage, and storage. Here you have the comparison between what has been forecast and what has been already awarded. So you see today we're rightly in this situation where 2022 is going to be a huge year. It's going to be 3 times more or less what it was last year, 2021. And you see that 2023 is already higher, twice higher than what 2022 is, which means that we are really in this scenario where people start to get awarded in advance for execution next year, etc., etc., which means to us that the business is going to be full at least until 2026. Okay. Independent are really leading the game, 60% of the market, more or less. It doesn't mean that the IOCs are not here. In most of the cases, if not all the projects of carbon capture we have in the database, IOCs are either operator for 10% of them or are a side partner, meaning they are investors in those projects, etc., etc. Usually, IOCs take a lot of shares in the joint venture of those projects. So IOCs can be a good player to jump on those projects as well. Another point which is really important for carbon capture usage and storage is that 90% of those projects, the FEED contract is converted to EPC, which means we are really into this new business model that we have been talking a lot already, where you need to be at the FEED if you want to enter the vendor list and if you want to get the order, okay? Because you will have no time and you will have no chance to enter at the EPC stage to sell your product, which means that you really need to be upfront, which means that you need to be today on the project, which are going to be delivered in 2023, 2024, etc., etc. Then a good door of entry for those projects is that, especially for the carbon capture and the carbon storage, it's a little bit becoming a license business. And you will see we have a slide about the licensing of CO2 capture, where it's really to the end of few players. And of course, as soon as your material or your equipment is referred into a license, okay, business is great because you are going to be resold every day and get all all the orders from your customers. But if you're not in those licenses, it's going to be tricky, and you're going to need to fight to enter those licenses again. Here, just to give you this idea about the main licensor, it's about 10 names you have on the left and 10 names you have on the right about carbon capture. All the name, I would say, more or less, you know them. Okay, we talk about Saipem, about Alstom, BASF, Fluor, Dosan, Shell, Aker, Hitachi, Mitsubishi, Air Liquide, Air Product, Praxair, Linde, Schlumberger. And then you have some players which are direct air capture, which is a little bit technology aside. But it means that by covering those 15 names, you have more or less all the licensing you will find for carbon capture. So that's all the market. That's where of course, as soon as you know where the carbon capture project is, okay, you have a foot, let's say, in the door to go on all the value chain of those projects. So those are the guys who have already trying to develop their license. Those are good door opener for you to do business. And those names, I mean, you already know them from, if you're from oil and gas or petrochem activities, of course, you already know, you're already in contact having customers in maybe half of those names already, which is good, which is good. No, but the location, and it's quite important to see the geography of those projects. Today, you have two big hubs for carbon capture and for the carbon business. The first hub is, I think, North Sea. The North Sea is a huge hub. It wants to become a little bit the reservoir of the CO2 emission in Europe. And of course, you have a huge concentration of projects there, carbon capture, but also storage and utilization. The second one is in the Gulf of Mexico, which is also an oil and gas region where you have a huge concentration of projects. And then I would say you have two side regions, which are Australia and so plus Southeast Asia, which are having a lot of projects, big one, and then Middle East, of course, because they want to reduce their carbon footprint from all their oil and gas activities. And the good combination to have, let's say, carbon capture, utilization, and storage project is either you have an industrial production with, of course, a lot of CO2 emission from the steel, the cement, etc., or the petrochem, or you have a lot of oil and gas fields which are depleted, and then you want to reuse those oil and gas fields to reinject CO2 underground. Or you have a combination of both, like the North Sea of the Gulf of Mexico. So of course you have the CO2 emission on one side, and you have the location to store them. So you are going to bridge, let's say, those two to join and reinject the CO2 produced underground. And that's why you have those two hubs, which are quite interesting. Now, if you mix those carbon capture geography with the timing, and here we try to find, let's say, a breakpoint between two eras. And this breakpoint is about 2024. Before 2024, and that's the graph from Project Smart Explorer, you see that per region, half of the project, 54 projects of the project are in North America. So you really, today, US are leading the game. Europe represents 1/4 of the project, and Asia Pacific, but 17%. Okay, Middle East is 3%, so it's almost zero today. In terms of feed, what we see is that, okay, 60% is US and Canada, a quarter is Europe, and for the EPC is more or less the same figures. Okay, so it's really engineering into the end of first the US and then the EU, but the project are a little bit having the same scope. Now, if we go after 2024, okay, and that's really the break here we see in the project, we see that the region starting with the biggest dynamic is Europe. Okay, projects are coming back to Europe. 60% of the market will be Europe, and then it will be 10% in North America and 10% in Asia Pacific. So Europe is really trying to boost this carbon capture for storage first, to reduce the carbon footprint of the company, of the societies and the countries, etc., etc., but also trying to make a big move in the second vision we are talking about on how to recycle the carbon and how to give value and monetize this carbon recycling. And then here the feed are moving again because they are coming back a little bit by this license business where we see, okay, feed still dominated by US and mostly Houston, not to say any names, but a quarter still being in Europe and a quarter being in Asia Pacific. But later on, when it goes to execution, where you have those licenses, most of it will be shared between Europe and US. Okay, so It's quite interesting to see this market because it's quite in regions which are well developed, where most of you are from, more or less. Either you're from US, from Europe, some of them from Asia Pacific. But you see that this market will remain in US and Europe, with decision center being in US and Europe as well. So it's quite interesting market to look at, because you may have less competition than on the oil and gas, where it's or petrochem, where it's a little bit more global competition you may have. About the dynamic today, we have touched a little bit about this topic, but to go in more details, today the projects are mostly pilot demonstrators, and we are seeing a little bit today project in operation, okay, or at least in execution. So pilot demonstrator, mostly small size, like the one I described at the beginning about Dunkirk, where the idea is really to decarbonize an heavy industry or to decarbonize an oil and gas field. Here, licenses today are being developed, if are not already developed, well placed. Not everything is fixed, so you can still enter source license, and that's I really encourage you to do it. Not everything is locked, but okay, it's in the process to be locked. In 3 years, and in this perspective of 2024, the trend that we see is to say, okay, first we'll capture the CO2, but we will also start to reuse it. The idea is not to store CO2 forever. The idea is to recycle the CO2 using hydrocarbon product, mostly green hydrogen. That's the perspective, or at least blue hydrogen, trying to make some product from that. And here, the project in the 3 years, the project and the UPC, they will remain in Europe and US. So it's quite a very interesting business that is going to happen, because the decision center and the project, they will be in Europe. Now the trend, let's say more long term, 2020, 30, it's a little bit, first, we know that the project and dynamics, it will still increase, it will still evolve. Now, this has been fueled by dynamics of those countries to reduce carbon footprint, to become sustainable, etc., etc. Does this trend to go sustainable will go through a carbon tax or equivalent global? That's a question mark. If it goes global, let's say there is a global carbon tax, or there is a global mandate for everyone to become sustainable, carbon capture will just explode even more than, and boom even more than what it's already doing. No, is it going global? Hard to say. Okay, it's not in my hands for sure, but let's see. Okay, things are moving so fast currently that we can expect it to become the case even before. In 3 years, for example, or you can, okay, because carbon tax has been a topic for 20 years already. Will it continue to be a topic for 20 years? I don't know. Just to split this evolution, today the evolution and the growth in size of projects, etc. But capture will grow, transportation grow, usage will grow. Storage, I would say, is a little bit different story, because as it's reusing more or less depleted oil and gas fields, which are depleted, I would say the storage capacities are well known, the field are already developed or already equipped with some equipment. So this part of this supply chain is already covered and already mature. But the other one, they would just go crazy and scale up, scale up, scale up. Going to a conclusion, and I see I'm still on time and still having few minutes for the question. So I invite you to start typing them. But I said a lot of things. Again, if you're interested by the slides, do not hesitate to tell me. But okay, here I'll read the takeaway from this meeting and from this webinar. Carbon capture, utilization, and storage is a market which is growing like crazy. Okay, every year it will multiply by 4, at least for the next 2-3 years that we see. And I can say that without any risk. And projects are also scaling up on top of that. So it means that it's more project, and projects are getting bigger and bigger. The investment is time 10, okay, more or less. So what was $500 million is becoming 5 billion now, and that's a little bit the two figures we see. Before 2024, it would be $500 million. Later on, it would be 5 billion tickets as an average. So it's scaling up in terms of project, but also in amount invested. So for sure, in terms of business opportunities for you, it's just a huge boom that we see on the market. Knowing that today we know that, okay, projects are growing, market is growing, but we have already a visibility so high until 2026 that we know that this business and this industry will be full of projects for at least 2026. And of course, many projects will come on top of it. Carbon capture, and what is fueling that is, of course, that it plays a huge role in energy transition for greenfield new development, but also to decarbonize many projects which are brownfield already existing. And it's really an easy plug-and-play solution you can have to reduce the carbon footprint of many companies which do not have the opportunity to go with green hydrogen or electricity. So it's a lot of, at the end, a lot of plants around the planet, a lot of industrial hubs that can approach this solution. Now, in terms of market, the maturity is not there yet. I would say it's more mature to a market if we compare it to green hydrogen, for example, or to renewable industry. Carbon capture is a little bit more mature in terms of technology and processes. We are not there yet with references, long arms, standards, etc., but we are going there. So it's really quite the last few months where you would be able to enter those licenses, etc. Knowing that here the market for carbon capture has two visions. A short term, which is really about storage. So we capture it, we store it, so we decrease our carbon footprint. And the long-term vision of carbon capture would be, okay, we capture it, and then we are going to recycle, reuse this carbon to do something else and have a negative carbon footprint, which goes really far beyond reducing the carbon footprint. As I said earlier, carbon CCUS is becoming its own industry with upstream, midstream, downstream. Many applications are under it. There is huge development in downstream, which are close to chemical, mostly industries. So of course, there is an opportunity here for you, and you have to select the application where you can sell your product, where you have any benefit and some advantage. And of course, it's a great opportunity to transfer the know-how you may have from oil and gas and petrochem activities to go into carbon capture and yourself to start to learn how to position yourself in energy transition. About the financing, I would say it was a big question mark last year, but we see it really flowing like really smoothly because on the long term, public money is coming on the table and huge volume of public money. And of course, a lot of companies start to have public mandate to decarbonate their industries. So they're putting money on the table to be able to say, okay, we are going to reduce our carbon footprint, blah, 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 blah. And of course, it's bringing a lot of projects on the table. Does not create value as it is straight away from the project by itself, but on the bigger perspective, of course, it creates a lot of value. And then maybe the most important point is that many of the opportunities they will remain in Europe and US. I'll put both Europe and US directly or indirectly. So for most of you, it's really close to where you are to fight for those projects and to also avoid some competition that you do not like. So it's a fantastic business which is growing up and which is really next to you, so you can go after those applications. So of course, if you want to go on this business, we can help you. So now it's time to go to the question.